Okay, well, I think at this point in time, we've waited several minutes after the hour. At this point in time, we are going to proceed with our onboard diesel fuel filter presentation. I am Aaron Keck, the application engineer, and today presenting with us is going to be Mr. Rob Sabo, our group product manager, focusing today on the onboard diesel fuel filter. So, Rob, take it away.
Thank you, Aaron. Good afternoon, everybody. Again, this is Rob Sabo with Schroeder Industries, and thank you for taking the time this afternoon to attend our presentation on HDP filters, which stands for Heavy Duty Diesel Pre-Filters. The product line that we have today is primarily used in regards to all diesel applications between the engine and the fuel tank of chassis. The applications that we have that we're going to discuss today are going to cover horsepower ranges from 50 horsepower all the way up to 2,000 horsepower. And they're done in a combination of three main products: the HDP 340, which is a 340 liter per hour unit, the HDP-BC 600, which is a 600 liter per hour unit, along with the HDP-HT, which is the high-tech version. In order to be able to meet the higher horsepower flow rates of these units, they can be manifolded together in units up to three, thus giving us the HDP 1800, which would flow 1800 liters per hour to accommodate the 2000 horsepower engines and above. When you look at the applications and the specifications on where our product is applied, you'll see that there are two main functions or two main filters that are present on a vehicle or a chassis where an application for a diesel engine is being used. The first part of that is on the engine itself. The on-engine filters today, which are called main filters, usually a 2 or 4 micron diesel filter, is not going to be the focus of our application today. It can be used, and if you do have engine manufacturers or OEMs that would be interested in this, we can do products of this, and we have many different main filter applications today. Usually that is a custom designed filter due to the quantities and the engineering requirements associated with that. But for the focus of today's discussion, we're going to talk about the HDP pre-filter, which is located between the fuel tank and between the low pressure pump feeding the engine. The pre-filters, both the high-tech and or the best cost, BC, has 7 micron filters, 10 micron filters, and 30 micron filters. The 10 micron filter is usually the standard in most applications that are out there, and they operate in the suction side of the filter. The reason these are being used is when you talk about the signs of fuel quality today, and there's been three major changes in the industry that have taken place. One is the advent of Tier 4 engines. The other is the addition of ultra-low sulfur diesel, along with the addition of biodiesel blends. What are the signs of bad fuel quality today? Typically, they're going to revolve around four main areas. HPCR, which stands for high pressure common rail repairs, which revolve around pump failures, injector failures, sluggish operation of the injectors. Other signs would be shortened filter life of the on-engine filters. These are usually due to the filters prematurely clogging and not meeting the regularly recommended service intervals. Those are typically anywhere from 250 hours to 500 hours, 500 hours being the norm for most engines that are out there. Other signs of bad fuel quality are after-treatment system failures and or shortened lives. This is primarily due to the fact that they operate on a very specifically metered amount of fuel that comes out of the compression chamber in the diesel engine. Water in the fuel systems, both free and emulsified, and the signs of bacterial or biological growth, either in the fuel tank and or clogged filters. What this causes in turn, though, is higher operational costs and expenses due to the high maintenance cost of the filters, unexpected downtime, schedule delays, reliability issues not being met, increased fuel costs. This in turn causes bad customer satisfaction. When we look at what a common rail engine is today and what is involved in that, again, key term here being used is what they call HPCR, high pressure common rail systems, or high pressure common rails. When you look at the high pressure common rail systems today, in the picture that you see is a picture of this on engine. This, as opposed to hydraulic applications in today's world, most high pressure hydraulic applications today operate around the 6,000 psi pressure range and or above. When we look at a high pressure common rail system as it exists today, We have very, very high pressures, those typically operating at 30,000 psi and above. These systems are moving into 70,000 psi systems and above. Today's injector openings are down to 2 microns, and they're moving to a half a micron in size. When you look at this, major fleets are experiencing many more pressures associated with bad fuel, both with the contaminant on the solid side of the equation, and then also with water ingression coming into these systems. You look at cost of injector repairs, and you take a small 4 to 6 liter system, and a high-pressure common rail injection problem can cost upwards of $5,000 and more. Most agricultural equipment or off-road or construction equipment and or genset equipment uses much higher liter systems, which in turn costs much more money to repair. One thing to note with regards to the common rail technology and Tier 4 requirements is it has been implemented on over-the-road vehicles since 2011 through 14. But in 2018, it is mandated that all off-road agricultural equipment, gensets, and construction equipment meet the mandates for Tier 4. Looking at the pictures that you have here shows the type of failures that occur within a common rail system today. First, what you'll see in the upper left-hand corner of the picture is what a common rail or high-pressure common rail system looks like on an engine. It consists of a pump, the rail, along with the injectors are feeding the compression chamber itself. Look in the lower left-hand corner, you'll actually see the injector poppet that is seated on the seat that's above in the upper right-hand corner. But if you look at the poppet and you look very closely at the pitting at the end of that poppet, that pitting is caused by traces of dissolved and emulsified water that's naturally in and needs to be removed from water within the fuel system itself. Water at those temperatures and 30,000 psi rail pressures will come out of solution, and they will cavitate the pump and create the pitting that you see on the poppet. If you look at the seat in the upper right-hand corner, what you'll see in a failed injector are the score marks. Those score marks are typically caused from either pump debris from a failed pump due to lubricity and or other contamination issues from water and or solids, and or from the on-engine filters bypassing. The on-engine filters will have a bypass mode in them due to the fact that you cannot starve the engine and cease power to run to that. The other thing that you'll see with the seat that's on there with the injector failure is it allows more fuel to go into the compression chamber than what was meant to. This increases both the fuel consumption and also can overwhelm the after-treatment systems that are utilized to reduce the NOxes of the gases that are being emitted from the exhaust systems of diesel engines. The next thing that's also a major factor in regards to water into the system today is the introduction of ultra-low sulfur diesel 15. That stands, ULSD 15 stands for ultra-low sulfur diesel at 15 parts per million. Over a course of the last few years, this has been reduced from 5,000 parts per million down to 500 parts per million, down to 15 parts per million. The problem with this scenario today and what is different in the market than how it has been in years past is ultra-low sulfur diesel, and how you get to that part is a process in the refineries called hydrocracking. It's basically using pressure and steam to reduce the sulfur content that's there. During this process, the naturally occurring lubricity agents that are found in the diesel fuel can be removed. It then calls for adding additives back into this fuel to increase the lubricity of the fuel. The USLD fuels also have a tendency of gelling 4 to 5 degrees sooner than the old low sulfur diesels. Many of the additives that have been used for years are less effective on this gas as it stands today. Another issue that is associated with this is ULSD 15 holds more dissolved water than low sulfur diesel at 500 parts per million, potentially causing larger water droplets in temperatures below freezing. The next advent is when you look at biodiesel blends. The addition of biodiesel blends, you may have heard this in the past, numbers like B2, B5, B10, or B15, is strictly a classification of how much biodiesel blend is added into the raw stock diesel. So i.e., when you hear a B2, it consists of 2% biodiesel blend. A B5 is a 5% biodiesel blend. The issue and the problem that we typically will have with this is biodiesel can have a tendency of having very high water absorption capabilities. Looking at a B2 can hold up to 250 parts per million, 500 parts per million for B5, and up to 1,600 parts per million for B20. The next thing is, if you look at the slide that shows the saturation curve for a typical biodiesel blend of B5, you'll see that the saturation point from free water to dissolved water and the saturation curve associated with that has a direct effect on the amount of water that is being held within the fuel. And this is based on temperature. The temperature, for an example, looking at this chart, at 80 degrees Fahrenheit during the day, as opposed to the evening when the temperatures drop down again, the water at cooler temperatures will fall out of the blend of the fuel and it drops to the bottom of the tank. The following day, when the temperatures rise again, this water is not resaturated into the fuel. It's pulled directly from the bottom of the tank and fed into either the vehicle and or the vehicle's injector system. Therefore, it's very important to understand and to have the ability to have fuel water separators that have the ability of removing the water from the system itself. Therefore, we'll start our discussion in regards to the onboard fuel filtration products, the HDP-BCs and the HDP-HTs. The HDP-BC stands for best cost. It is a manual drain. The manual drain on there, because of this being on the suction side of the equipment, does need to have the equipment turned off to be able to remove the water. There's a clear bowl at the bottom of this that shows the amount of water that's been removed. There's also a sensor that can be installed called a whiff sensor. A whiff sensor stands for water and fuel. With the HDP-600, there's also a hand priming pump option. The main difference between the HDP-BC and the HT is the HT was developed, high-tech version is what HT stands for, with an automatic water drain and an automatic whiff sensor. So when the whiff sensor detects the water in there, and it gets to a certain level, the automatic drain will discharge that water without having to turn the vehicle down and or off in operation. In certain applications, this is critical. Mining applications, genset applications, and or other critical applications where the equipment cannot be turned off. As you'll see with both of those units, from 1.5 GPM all the way up to 7.9 GPM, and they can be, again, put and plumbed in parallel and or in series to be able to acquire these levels. The next slide on here just gives an overall basic view of the HDP-BC, the onboard coalescing filter with the manual drain. It is rated to a negative 40 degrees all the way up to 194 degrees with a 24-volt option and or a 12-volt option available. That's primarily used for the fuel preheating option, which is a full-flow fuel heater. That's primarily used in low-temperature applications or cold weather applications where the diesel fuel have a tendency of gelling and becoming thicker. Cold starts can be an issue. The fuel heater will help this process during cold starts. Porting sizes are available in metric thread, and just recently we've introduced the new SAE 12 porting thread. On the HT version, high-tech version, very similar operation. One thing that should be noted on both of these units, especially on the BC version, is this unit is built in a very modular format. So it is possible to buy a base unit of this, and if the customer and or the OEM needs to upgrade or wants to upgrade these in the field with a whiff sensor and or fuel heater, that is possible without buying a new unit. The automatic drain version also too should be noted that Schroeder is one of the only companies out there that has this technology. All other fuel filter water separators that are out there are done with a manual drain operation. So that is unique to us. I want to say thank you very much for you all taking the time for our presentation this afternoon, and I hope everybody has a great week.
Whether it's a helpful how-to or a new product release, Schroeder Industries is your place for fluid filtration. Subscribe below.